So here I will add the breakpoints. As we can see, the first four statements will be is are variable declarations. So all these variables will be held in local variables, but they have not been assigned any value. Now if I continue, I move on to the next statement. So the line number 13 will now be executed, and it will be the buff1 R1 will be allocated a memory space in heap, and we can see that here buff1 R1 has a value, has a memory address assigned. Now if I continue and I move on to the next statement, buff2 R1 will also have a memory allocated in space, and we can see the address assigned here. Now if I continue, I'm executing line number 15, and it will free buff2 R1. So buff2 R1 still has that same value. Now if we continue, buff2 R2 will be allocated in heap, and it will have a memory address same as buff2 R1, because buff2 R1 has been released, and buff2 R2 will have the same location that was freed recently. Now moving on, buff3 R2 will be allocated a space in heap, and this is the memory address assigned. Now if I continue, strn copy function will be called, and also I wanted to talk about call stack. Here these numbers indicate the stack frames that have been created by the program. So 0 indicates that main function was loaded in the stack. 1 indicates the main function was loaded in the stack, and 0 indicates call to strn copy. But here the program crashed as it encountered a segmentation fault because of buff2 R1. In the program earlier, we released buff2 R1, and doing a string copy was using buff2 R1, was trying to copy into buff2 R1. So it created a buffer overflow vulnerability. So how we can fix this is that if we do not free buff2 R1, it could still be used, and we could easily assign without running into any error. So that's for program 1. I'm going to continue with another program. Second program. Okay. Give my breakpoints. Okay. If I start, it has declared the variables I and p. I is initialized to unsigned integer value, and p has been initialized to 0. Now if I continue, I'm into the for loop. Value of I will become 0. Now if I continue, I come to line number 8. Malloc function will be called, and p will be given a memory address in heap. Now if I continue, p equal to I will happen, and value of I will increment to 1. Now if I continue, malloc will be called again, and value of p will change, and it will give a new memory address in heap. Now if I check the value of p using this memory address, I see that no value has been assigned to p. Now if I continue, value of I becomes 2, and if I use the previous command and I check the value of p at this memory address, I can see that 1 was assigned to this, which means that every time we are calling malloc p and not freeing it, means it is creating a dangling pointer, and p will be referring to another memory address each time, and the previous memory address, previous pointer will get lost. So it is a good idea to use free if you do not want to miss those memory addresses. I'll set my breakpoints. So now I've entered the main function, and the main function, the main has been loaded in the stack. So stack frame has been created for main method. Now if I continue, I will go to the plus method, and the return address will be pushed onto the stack. If I continue debugging, a malloc function will be called, and p will be given a memory address in heap. So this is the address. If I continue debugging, I will execute line number 6, that is a plus b, and p will have a value of 3. We can check the value of 3 over here with this statement. At this memory address. So we can see that p has a value of 3. Now if I continue, I will return, and stack will be the stack frame for plus method will be deleted, and I will come back to my main method and try to print f. So when I print f, it will show the value 3. Now I will execute free, and once I execute this statement, it will free up the memory for p, and it will also remove this main function from the stack frame. So now if I check the value for p at this location, I see that it is not accessible anymore. Debugging it. So once I start, it will load the main function in the stack, and stack frame will be 0. Now if I continue, it will make a function called to plus method, and a stack frame will be created for plus method with stack frame 0, and main will have a stack frame of 1. Now if you want to see the variables that are stored in the stack frame for each of these methods, we can see with reference to this. So plus method will have variables a and b stored along with variable c, and frame 1, which is for main method, will have p variable. Now if I continue debugging, it will return the value of c, and will have value of c as 3. It will move to the main function, and p will have a value of 0, and it will also delete the stack frame for plus method. If I continue, it will come out of the main method and delete the stack frame from main method as well, so it has freed up all the memory. This is problem 4. So once I start debugging it, main is loaded in the stack, and a has a value of 0. If I continue, the address of a will be printed, which is something ending with 96fc. If I run the program again, I can see the value of a is something ending with 2ccc. If I run it for the third time, I see it's a different value again. So every time I run this program, different values of a have been printing. all this is a garbage value because address randomization is turned on. So every time this program is run, A is located in a different location.